In this video, we're going to explore what is known in geometry as transformations. And if you've ever seen if you've ever been a fan or seen the movie Transformers, you know that the word transform basically just means to change, right? And so Transformers, of course, are these giant robots that could change forms into different types of vehicles and stuff like that. But the key thing was that they were changing. And so what we're going to look at are three different ways that we can change the position of geometric shapes by following some rules. Now, the first type of transformation we're going to look at is something that is called a translation. And a translation is also sometimes referred to as a slide, because really what we're doing is we're not changing the orientation of the shape at all. We're just changing its position by kind of sliding it around on the page. So the key to doing a transformation is that you will be given a translation rule. So in this case, the rule is x, y, and then the arrow means the slide, and then this x plus 8, y minus 3 are the rules or the directions of how we're going to slide the shape. And it looks really complicated, but it's actually not that bad. So the first thing we need to be able to sort of figure out is the code that this sort of translation rule is giving us. So x is just referring to the object's position in terms of right or left. And the y is referring to the object's position in terms of up and down. And so just like we did our work with integers, right? Positive integers moved one direction and negative integers moved the other direction. Well, it's kind of the same thing that's going on here, where what we have is if we want to slide an object to the right, then we will indicate that using a plus sign. And if we want to slide an object to the left, we use a minus sign. And likewise, if we want to slide an object up, we use a plus sign. And if we want to slide an object down, we use a minus sign. So we can kind of use this key to kind of unlock what's going on in the rest of the rule here. So the first part of the rule that we're going to take a look at here, and I'll highlight this another color on top, is this part here, the x plus 8. So what that's really telling us, remember x refers to right and left, and it's telling us, because there's a plus sign, that we want to slide this object to the right, because of the plus sign, 8 spaces. So if you look on the grid below, we can kind of see that it's a grid. So we're going to move 8 spaces or 8 squares to the right. And then the second part of this is the y minus 3. So remember, y refers to up and down, minus refers to moving down, and then the 3 tells us how many units down we're going to move. So putting these two things together, what we can kind of see is that we are being expected to change the position of this shape by going to the right 8 units and then down 3 units. So those arrows here just kind of give us a general idea of what's going to happen. So let's actually do this. So the first thing I'm going to do is I'm going to start at point A, and I'm just going to actually count on the grid. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8 units to the right, and then down 1, 2, 3 units down. And this point here represents the new position of A, and we're going to call that A, and this is called prime, A with a little tick mark. That tells us it's the new A. And then we'll do the same thing with B, and so B goes 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. So here's a new point for B prime. And then C, we do the same thing. We go 8 over and 3 down. Or another way to look at it is that we know that C is 1, 2, 3, 4 units over from B. So it's still going to be 4 units over. 1, 2, 3, 4. And that's going to be the new C, or C prime. And so let's just kind of quickly draw that in. I'm drawing this by hand, so it'll be a little bit messier than normal. So there's my AB, my BC line. Here's my AB line. Oops, this is a disaster. And then there's my BC. So here is my new triangle, which is triangle A prime, B prime, C prime, and it's been moved according to this translation rule. The second type of transformation we're going to look at is what is called a reflection. And sometimes reflections are referred to as flips, because what we're kind of doing, if you could kind of pick this triangle up, is we're flipping it kind of over this line. And so, it's like the idea of looking in a mirror or reflecting something in this line J, which is kind of like acting as our mirror. So an easy way to do a reflection is when you have a grid, is really all you're doing is you're counting how many spaces away from the mirror is each of your points, and then you're just sort of reflecting that on the other side. So let's actually take a look and see what I mean by this. If we look at point A, we can see that point A is 1, 2, 3, 4 spaces away from the mirror. And what's really important here is that sometimes the mirror is rotated so it's not exactly up and down or vertical or horizontal, but you need to make sure that that line that you're drawing is actually a 90-degree angle to the mirror. So point A is 4 units away from the mirror, so the new point A also needs to be 4 units away from the mirror, but on the other side of the mirror. So 1, 2, 3, 4. So my new point A is going to be over here, so this is A prime. And I'm going to do the same thing with B. B is 1, 2, 3, 4, 5 units away. So the new B will be 1, 2, 3, 4, 5 units on the other side of the mirror. So that would be B prime. And then finally, point C will be, it's only 1 unit away, so it will still be 1 unit away on the other side of the mirror. So let's just plug that in there, C prime. And then once again, because this is, I would need to draw in my final shape. So there's B to C, A to B, and C to A. And I would expect that you would use a ruler to do this. So here is the new shape. This is the reflection. And you can kind of see that if you can imagine kind of picking that up and flipping it over the line, this is what it would look like. The final type of transformation that we're going to look at is what is known as a rotation, and sometimes this is referred to as a turn. Now these tend to be the more complicated ones because there's actually lots of information you need to know. The first thing you need to know is you need to know how far you are going to rotate your object. So in this particular case, my how far is represented by the 90 degrees. The second thing that you need to know is you need to know what direction am I going to rotate, because I can rotate things clockwise or I can rotate things counterclockwise. So in this particular case, it says here that I am rotating clockwise, so that's good. And then the final thing that I need to know is I need to know what is referred to as the sort of point of rotation. So I need to be given some information so I know what I'm rotating this object around. And so in this particular case, my point of rotation is point L. So I'm going to make that green just so I kind of know that that's my point of rotation. Everything is rotating 90 degrees around that point. So once again, this is where you need to know your angles a little bit. So the first thing I'm going to look at here is point K. Point K is 1, 2, 3, 4, 5, 6 units away from L, and it is directly horizontal. So if it's horizontal, it's now going to be vertical, right? I need to rotate that line 90 degrees. So if I go 90 degrees clockwise, the new line K is going to be 1, 2, 3, 4, 5, 6 points directly above L. So this is going to be the K prime. L prime will be in the same spot. And now I can kind of do the rest of these here. Sometimes it's enough just to kind of find one new position, because then you can use this to kind of draw the rest of your shape. So if I notice that point N is 1, 2, 3, 4 spots below point K, well, that means the new N is not going to be below point K, it's actually going to be beside point K because it rotates clockwise. So it's going to be 1, 2, 3, 4 points over here. So there's point N prime. Then I can see that point M is 2 spaces away, but now if I rotate that 90 degrees, it's actually now going to be below. And then I just have to connect up M and L. So I get my new shape, which has now been rotated 90 degrees. And once again, if you have a physical piece of paper, this is actually really nice to do because all you have to do is put the piece of paper and then literally turn it 90 degrees clockwise, and you'll get the new position. So hands-on approaches to these types of translations really are helpful.